Hello, my name is Carlos Borras, and this is week 9 project. And this week we're trying to prove the equilibrium, the divergence of S plus the body force is equal to 0. And so this is what the stress tensor looks like. I just wanted to mention that for here what I wrote is the absolute value of x1 in several occasions. That's what I did last week. But on this week I decided to go with just x1, no absolute value. That's why you will see some negative value for this sphere and positive value for this sphere. So the divergence of the stress tensor S looks like this, just like we saw in class. It's just the partial of Sij with respect to Zj in the direction EI. And for equilibrium to hold, this condition must be true. And this is what the stress tensor looks like, just like this one, but as you can see, without the absolute value in any of the x1. So for the body force derivation, we just follow what we mentioned before, the partial of the stress tensor with respect to Zj in the direction of EI, and this is what it looks like. Um, so what we need to do now is for the body force, we need to calculate the triple integral. And what we need to do is substitute this x2, x3, and x1. There's no x1 left on my body force, but just in case we needed to, these are the parametrizations. I ended up going with sphere 1. So what I did is for the body force in the sphere, I just substituted x1, which we really don't have, then x2 and x3 uh, here in each of the directions of the vector. So I used a non-line integrator to help me calculate because this was going by hand. I mean, it doesn't look terrible, but trust me, it is. So I ended up using a non-line calculator. I didn't want to complicate my life too much. And so it ended up giving me negative 13,404, negative 26,808, and 0 for the z direction. And body part 1 is exactly the sphere one, and this is basically what I got. I think Wolfram could have given me more significant figures, but this is what it gave me. So it's basically what we got from the code. There's one thing I wanted to mention, and I'll show it on my code. Um, just give me 1 second right here. Oh, oh. I put a space when I was running the code. Real quick, this is what the body looks like with the stress tensor. And here, what I wanted to mention is on the surface 1 and 2, which are the spheres, for some reason the direction E3 is not giving me the right numbers. These two should be 0, just like they are here in the volume. And as you can see in the direction E3 for the body force calculation on the cylinder is exactly the same for the area of the surface here. So for some reason these should be 0, and that's why there is no equilibrium on the E3 direction. Um, E1 and E2 seem to hold just fine, but on the E3 direction it was not holding. I need to fix that on probably the normal vectors. I'm assuming that that was what my issue was. But for the rest, at least in the calculation of the triple integral, this is holding, and everything else should be fine. Thank you.